So the year is 1971. While microprocessors were starting to be seen in calculators, many had seen how MOSFETs had given rise to the mini-computer and wondered whether microprocessors could be used to make an all-new type of computer. A home computer. One such person was former NASA engineer Gus Roach, who set up a company in 1968 called Computer Terminal Corporation, CTC, to manufacture terminals for mainframes and mini-computers. Roach was determined to produce a personal computer, one that was small enough to fit on a desk, but could perform more work than acting just as a terminal. His designs highlighted the need of a single 8-bit microprocessor, the CTC 1201, rather than a more traditional approach of a collection of TTL logic chips. There was just one problem. At the time, no one had ever manufactured one. Roach knew this, so approached two chipmakers to ask if they could manufacture the microprocessor. One of these was Texas Instruments, who were a large producer for integrated circuits and logic chips. The other was Intel, who mainly produced memory chips. Texas Instruments attempted to produce the chip, but it suffered from reliability problems, and thus development was not continued. Intel, who were in the early days of developing the 4004, didn't see much point to the project. For them, memory was a far bigger priority. Nonetheless, they decided to take on the project and got to work implementing CTC's design. Initial progress was good, but it suffered delays, and Intel could not meet CTC's time schedules. As a result, CTC decided to abandon the single processor design in favour of a multiple chip approach. Intel continued working on the chip, however, and a year later released it as the Intel 8008, the world's first 8-bit microprocessor. Since the 8008 design was based off of CTC specifications, their computer, dubbed the Datapoint 2200, was completely instruction compatible with the Intel 8008, despite not using the processor. The 8008 was soon replaced with the 8080, which improved compatibility with existing TTL chips, had a much higher clock speed, and included a larger 16-bit address bus. This caught the attention of calculator manufacturer MITS, who had used the 4004 processor in some of its designs. Ed Roberts, the company's founder, knew that the 8080 was powerful enough to be used in a home computer, but the chip's high price meant that it wasn't commercially viable to do so. As one of Intel's largest customers, Roberts was able to negotiate the price down from $350 to $75 per unit. This led to the creation of the Altair 8800, generally considered the first commercially successful personal computer. The 8800 was popular with a generation of computer scientists and engineers who had learned computer programming at college but no longer had any hardware to use. Several other home computers followed suit, and the chip also appeared in early arcade games such as Tato's Space Invaders. Soon after, more designs appeared on the market. The Motorola 6800 was released just 4 months after the 8080 and saw use in several early home computers. Motorola had been a huge player in developing transistor-powered electronics, and were confident that their chip would be successful. However, poor decisions by management led most of the design team to walk out around the time of its release. The team, led by engineers Chuck Peddle and Bill Mensch, would join a small semiconductor company called MOS Technology, who are best known for creating the processor for Atari's Pong. They got to work by taking the 6800 design and removing the features that were deemed unnecessary in order to drive costs down. They removed one of the accumulators, simplified the memory bus, and shrank the instruction set by 25%. Another dramatic cost saving was achieved by modifying the masking process in the silicon to significantly improve yields. This allowed MOS to have a defect rate of less than 30% compared to the 70% rate of competitor foundries. The result was the MOS Technologies 6501 and 6502, first shown at the WestCon 75 trade show in San Francisco. The 6501 was pin compatible with the Motorola 6800, whereas the 6502 was a modification of the 6501 design with an on-chip clock oscillator. The result of the cost saving meant that the 6502 could be sold for just $25 compared to the $175 of the 6800 and the $350 of the Intel 8080. The news was covered in great detail by the technology press, and the product was soon in high demand. However, Motorola were furious with the 6501's compatibility with its pin layout, and sued MOS Technology, citing patent infringement. MOS, being a small company, settled with Motorola and stopped selling the 6501. But this wasn't an issue, since the 6502 was far more popular, and Motorola made no such demands regarding that chip. In fact, Motorola knew that the 6502 would be successful regardless. 2 months after the chip was released, they reduced the cost of the 6800 from $175 to $69. 9 months later, it was dropped again to $35. But it was too late. Everyone knew the 6502 was king. The chip was used in a whole host of early home computers, including the Apple II, Commodore PET and VIC-20, Atari 400 and 800, and the BBC Micro. It also found success in the emerging home video game market, powering the Atari 2600, the Atari Lynx, the TurboGrafx, and the NES. Despite the success, the legal battles with Motorola had bled the company of funds, and so they were taken over by Commodore in late 1976. Commodore would fully utilise MOS Technology's expertise with the Commodore 64, which used a lightly modified 6502 chip, the 6510. The 6502 had massively disrupted the market with its high performance and low cost, but it soon faced competition of its own. The head engineer of the Intel 8080 project, Federico Fajan, soon left the company after its completion and started Zilog Microcomputers with fellow Intel engineers. The team took the 8080 design and added several improvements, a whole host of new instructions, reduced the number of support chips required, and introduced new indexing registers that made repeated execution faster. This chip was released as the Zilog Z80, and while its intended use was in embedded systems, it was soon widely adopted in the home computer market. The chip was featured in the Amstrad CPC, various MSX computers, the Radio Shack TRS-80, and the Sinclair ZX80, 81, and Spectrum. Like the 6502, the Z80 also found its fair share of success in the video game industry, powering the ColecoVision, Sega Master System, and Sega Game Gear. In addition to home systems, the Z80 was the go-to processor for the emerging video arcades. It was the chip that powered Donkey Kong, Galaxian, Galaga, Pac-Man, Mario Bros, Frogger, and Berserk. But this was just the tip of the iceberg. The Z80's success would not come from its use in home computers or video games. It would come from software. The Z80 was the de facto processor to run CP/M, the world's first successful cross-platform operating system. CP/M was originally built for the Intel 8080, but being fully compatible and cheaper, the Z80 was the obvious choice. Due to the cross-platform nature, CP/M quickly gained a large software library, which made it the dominant operating system in the late 1970s and early 1980s. One such example was WordStar, one of the earliest word processors to gain commercial success. Its "what you see is what you get" interface gave it a clear advantage over existing fully text-based word processors. Another example was Microsoft's Multiplan, an early spreadsheet application that would become Microsoft Excel 3 years later. In fact, Microsoft were a key developer of CP/M software, and recommended using the CP/M operating system to partner IBM, who were in the process of developing their own home computer. However, Digital Research, the company who created CP/M, were not happy with IBM's contract, leading Microsoft to abandon this plan. They instead purchased 86DOS, an imitation of CP/M that had been designed to take advantage of Intel's new 16-bit 8086 processor, and renamed it to MS-DOS. This was then licensed to IBM, who used it in their 1981 product, the IBM PC. Powered by a cheaper version of the 8086, the 8088, it was an instant success, and the MS-DOS operating system quickly overtook CP/M in market share. The proliferation of different microprocessors and architectures created a golden age of home computer technology in the early 1980s. The adoption of computers rapidly increased in both home, education, and in the workplace. However, by 1985, IBM were clearly ahead. More than half of the home computers in America were IBM's. The original IBM PC had sold well, but the recently released PC-AT led the industry with its blazing fast Intel 8286 CPU. The PC-AT was so fast that IBM had to purposely slow down the chip to not cannibalize its mini-computer line. Faced with dwindling sales of 8-bit computers, others in the industry needed a microprocessor that could keep up. Thankfully, this already existed. Introduced in 1980, the Motorola 68K was first used in high-performance systems, such as the HP 9000 series and Silicon Graphics Iris workstations. However, by the middle of the decade, prices had become low enough that use in a personal computer would be cost-effective. The 68K was perfect for the next generation of home computers. Its forward-thinking 32-bit design and high clock speed meant that it was suited to graphics-heavy workloads. It would be the chip to power the Apple Macintosh, the Commodore Amiga, and Atari ST home computers. With IBM PC compatibles dominating the office space, these new machines would position themselves as creative workstations. The Macintosh, by far the most popular of the three, had Aldus PageMaker, a desktop publishing application which allowed the Mac to rule the desktop publishing space. The Amiga had Deluxe Paint, a digital graphics editor, and the Video Toaster, a video production suite. And the Atari, with its built-in MIDI ports, was a music production powerhouse, with software such as Cubase and Logic. By the late 1980s, the market was made up almost entirely of PC compatibles and 68K powered machines. IBM, who had led the market with the PC and PC-AT, did not want to lose its influence, so released a new lineup of computers in 1987 called the PS2 series. The more powerful PS2 machines used the new Intel 8386 CPU and offered a range of new features. One such feature was a new expansion bus called Microchannel Architecture, which was designed to replace the existing ISA bus that had been used on previous IBM machines and PC compatibles. IBM had patented the new bus and charged license fees to companies who wanted to use it. The move was met with poor reception though. It was seen as a desperate attempt to regain control of standards during a time when IBM's grip on the personal computer market had been ever slipping. PS2 machines sold poorly, and PC vendors worked together in a consortium to create standards outside IBM's influence. By 1990, it was clear that IBM had lost control of the industry. Management issues at Atari and Commodore had meant that both companies struggled in the early 1990s, effectively ending support for the Amiga and ST computer lines. This led to a bloom of Mac adoption, with Apple becoming America's #1 computer manufacturer during this time. However, even the newest Apple machines could not compete with the latest PC technology. The Intel 8046, released in 1990, was twice as fast as the outgoing 386. This was achieved by using an inbuilt floating point unit, an on-chip L1 cache, and advanced pipelining. The Motorola 68040, which drove the most powerful Mac systems, could beat the 486 clock for clock, but simply couldn't get to the clock speeds without reaching furnace-like heat output. The market was now segregated into two sectors: the more niche Motorola-powered Macintosh, and the widespread Intel-powered PC. One thing was for certain though: the PC was winning.